This next video is showing you how to use MATLAB to do the comparison from the Excel plots. So the first thing to do is open up MATLAB or go to MATLAB using the network connection. So I already have signed in, so I am connected to the network. If not, follow the procedure in the video on remote access. And then I open my remote desktop so I can connect here. I've already connected, so I'm going to bring that up. And then you're going to go to the Start menu and open up MATLAB. So here I can do what I did in Excel, which is put in all of the variables. So I have R1 was 10, R2 20, R3 20, and C is 10 to the minus 9. I can then also make the parallel equation, and then I can put in the transfer function that I'm going to put in here. I can actually plot it with these variables, and therefore it will make it easy as a designer to change those variables and see what effect they make. So to do the Bode plots in MATLAB, you have to type this, which is S is equal to TF, which stands for transfer function, and then the variable you're going to use in the transfer function, which I'm using S. So then I type in the transfer function itself, which is R2 times R3 times C over R1 plus R3. That whole quantity was multiplied by S and then divided by the R2 plus R1 R3 pair, which is what I called that, times C times S plus 1. So this is my transfer function. I just type it in. And now I want to plot, and all I have to do is type Bode H. And my transfer function Bode plots will come up. I can then change these. I can change the grid. I can change the x-axis and so forth, like you've probably done previously. And I want to make some comparisons, so I'm going to actually minimize this window. Make these a little bit bigger. So I see here that this is in radians per second, the magnitude is in dB, and the phase is in degrees. And you can see that it is a semi-log graph here. So now I can do my comparison between the Excel that I created and this. So I can change the axes to be the same. This one goes from 1 times 10 to the 5th to 1e to the 8. And that should give me the same looking graphs. And I see that I have about minus 10 here. And this is about minus 10 here. And it slopes down and about 1e to the 7th. And you can see here again it slopes down. So these pretty much are the same graphs. For my phase, I again can change the axis to look similar so that I can do an easier comparison. And I see here that yes, it does look very much the same. Because I don't have a lot of points in here, MATLAB goes through this with a very, very small points between each value where I have kind of big jumps. So you can see that that is where the difference is. So in MATLAB, one easy thing that you can use is that when you click on the graph, it actually brings up the frequency and the magnitude. So you can see here as I move this, that my magnitude is pretty much maintaining almost a fixed value. So it's not changing very much along this. So that flat line is called the bandwidth of the system. And so at the point where it changes from this flat value by minus 3 dB is called the 3 dB cutoff frequency. So as I look at this and I have a fixed value of about minus 6 dB, I'm going to go and move it down until I get to a minus 3 dB, and that is going to be my cutoff frequency. Or since it's going down, it will be minus 6, minus 3 will be minus 9 will be my cutoff. So I go up until I get to be about minus 9, and I can look at the actual frequency of 3.77 e to the 6 would be what I would consider my cutoff frequency at the minus 3 dB point. And once I'm done with this, I can close the remote connection and also log out of the network.